Hello, and happy Wednesday. Good news, I brought Squirrel back to the table. Squirrel, you gonna say hi? Squirrel, we promised. We shook on it. I gave you my paw, and then you gave me your paw. Nothing? That's just sad. All right. Squirrel may or may not be joining us. She was not pleased with the settlement we reached, so she might be taking it out on me. All right, let's take a look at arithmetic. So, yeah, arithmetic, that's the one that you missed. What? I can't help that you missed it. You were on strike. What? What are you doing playing with that? It's ridiculous. Okay. So this happens whenever we are adding. What we had to do is we had to use the equation. And we were using the equation an equals a1 plus n minus 1 times d. And so you had to fill in all of that information. So in the first one, it would be an equals 0.1 plus n minus 1, and the d every time we are going up 0.1. You would distribute the 0.1, and in the end, this is the answer that you would get for that. So I've got the answers for the front. Check over the front to make sure that you've done it correctly. Make sure your answers are right. Some of you still struggling with the distribution, so that's a problem. What are you doing? This is not hockey time. Mathlete versus athlete was yesterday, and you refused to dress up as an athlete. I had a beautiful sweatband that I was going to give him. Anyway, on the back, so we've got the closed formula. We had to find the first 5 terms, so we plug in 1 here. 6 times 1 plus 1 is 7, and then we erase the 1 and we plug in 2 there. So 6 times 2 plus 1. And then 6 times 3 plus 1. And you could do it that way. You could also, once you found the pattern, just keep going. And then for the last 4, what you had to do is it only made you plug in 1, but it was a very random one. So like this one was the last one. I like the last one. The last one was 23. So really, we're going to put 23 right in there, put the parentheses. You type that into your calculator. This is what you get. Some of you got a fraction, particularly if you're using your calculators, because that defaults to fraction. I got a decimal. It doesn't matter which one you go. And that is how we do arithmetic sequences. If you have issues or questions on the homework, please message me so that we can get those squared away before your quiz tomorrow. Tomorrow's the quiz, Squirrel? Squirrel, do you remember when I said the quiz was? We should figure it out. Okay, this is our goal for today. Today is geometric. What on earth was I doing? That's just pathetic. Tomorrow is your quiz, Thursday the quiz. For labs, I wanted to tell you we are going to be doing that Regents Review packet. And for algebra, I want you to work on pages 23 through 34. That is actually going to be what your break packet is. Your break packet is pages 23 through 34. Now that's a good more than 10 pages. So it's going to be a lot of work. You might want to start now while I'm here and can help you, and you can message me and we can get this done. Over the break, I will be giving a few videos to do some of the very, very difficult problems, but a lot of them are straightforward problems. If we take a look at that, this is what the packet should look like. It should have come by bus, either Monday or Tuesday. I think it's Monday. It came by bus. And we want to start with page 23. If we go all the way to page 23, which is a lot of flipping, and yes, we'll have to do all of this before the Regents. Aren't you so excited? 23, if we look at page 23, it doesn't actually have any questions on it. These are just examples of how to solve systems of equations. So I want you to look at how I've solved systems of equations. Your actual first question starts on page 24. So some of the questions are grayed out. Those are the questions. And then the white sheets of paper are just a reminder of how to do it. All right, so that is going to be what you do for lab for the rest of the week, and it will be what you do over break. As I say, today we are going to be doing a lesson and then quiz on Thursday. Who's excited? Today's geometric, tomorrow's our quiz, and then Friday's fractals. Fractals has a very special place in my heart. All right, let's talk about today's notes. Okay, the people who came up with this arithmetic formula were very, very smart, and it was very, very good. And everyone looked at them and they were like, awesome, you have figured out how to deal with adding and subtracting. Good job. How do we multiply and divide? And they were like, use the recursive formula. And they were like, bad answer. So the mathematicians had to go back and take a look at multiplying and dividing. I swear that's how it happens, squirrel. Don't you dare call me a liar. I see you trying to call me out. Actually, may or may not have lied on that. I don't think that was historically accurate. But anyway, they were like, the mathematicians who came up with this decided, hey, we've got a beautiful closed formula for arithmetic. So if I want to find the 100th number in an arithmetic sequence for the adding and subtracting, that's great. I've got a closed formula. Can we do the same for multiplying and dividing? And the answer is yes. So we got example here, 6, 12, 24, 48, 96, dot, 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 dot. Yeah, it keeps going. It keeps going to infinity, squirrel. And the first thing that we do is we talk about recursive. Now, on Monday, we learned how to do the recursive formula. The recursive formula was how do we start out, and then what do we do after that? We start out with 6. So 6 is going to be where we start out. And then each time we go from 6 to 12 is not times 6, but nice try. Times 2, times 2, times 2. Okay, so in order to get an, we have to take the guy before it, and we have to multiply that sucker by 2. And that is how we would say the recursive formula if we were doing what we did on Monday. And that would be awesome. That would be very exciting. And sometimes the Regents will ask you to do the recursive formula, and that's not too bad. The problem is if they ask you what is a of 100. If they ask you what is a of 100, you do not want to sit there with your calculator multiplying by 2 100 times. That is a terrible idea. So we are going to have to go to the closed form. And just like the arithmetic, the closed form is on our reference sheet. And hey, guess what? It is right there. For algebra, the quadratic formula is important, the arithmetic sequence and the geometric sequence are important, and then these conversions up here. Very rarely will they ask you to do anything with area or volume. Sometimes they ask you about the Pythagorean theorem, but not normally. This is all for geometry. This is for algebra 2. No one knows what that's for. That's just for fun. I feel like they were just having fun there. That's not useful. All right, so let's take a look at the geometric sequence. It says A1Rn minus 1. So if we go back to here, we've got closed form is A n A1R to the n minus 1. Now remember when we had y equals mx plus b and there were only certain things that we subbed in and we left y and x alone? Yeah, we're going to do the same thing here. We're going to leave this one alone. So this is going to be my variable. And of course my n is going to be my variable again. A1 is our start. R is our rate or our ratio. That's the ratio. That's how fast it is going up. So in this case, it's going to be multiplying by 2. Yeah, well, it said ratio because sometimes it's a fraction. Like if we're dividing squirrel, it's a fraction. So you have to be careful on that. So for this one, it's going to be AN equals, A1 is going to be 6, and then our R is we're multiplying by 2 each time, and then n minus 1. Now notice, this n minus 1, not on the ground. That's an exponent. You leave the exponents alone. So we are completely done with the closed form. Closed form is actually easier than the recursive form for geometric, which is super exciting. So if I wanted to find A of 100, I would just plug in 100 for n, and it would be 6 times 2 to the 99th. Because 100 minus 1 is 99. Makes sense. All right, let's try a division one. Before I set you free, let's try to divide. So we've got 27, 9, 3, 1, a third, dot, 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 dot. If we were doing the recursive form, like we did it on Monday, it would be A1 and AN. We would be starting with 27. And in order to get to AN, we would have to take the guy before it, and we would have to do something to it. We would have to do divide by 3. Do you see how we're dividing by 3 each time to get the next number? So you could write divide by 3, but there are other ways that we've written that. We could do over 3 like this, or multiply by 1/3. Dividing by 3. I want you to write this down in your notes. Dividing by 3 is the same as multiplying by 1/3. And guess what? Dividing by 2, same as multiplying by 1/2. Dividing by 7 is the same as multiplying by 1/7. Dividing by 8, same as multiplying by 1/8. So let's do our closed formula. We've got A sub n, A1, R, and n minus 1. We're going to keep the AN. A1 is 27. Our R. Now remember how I said that this is a ratio? We're going to have to use this fact that we just talked about. We can't just say divide 3. That's not legal. We have to say 1/3. Because each time we are multiplying by a ratio of 1/3. Be very careful. That is how you do division. You can't say divide by 3. You have to put it into a fraction. And then, of course, our n minus 1. And there we go. So that is how we have to do geometric ones. Very similar to arithmetic in that we have the two different ways we can write it. And one is helpful if we're just quickly doing it and they just want the pattern. Another is much more helpful if they want to find the 100th number of something. Okay, let's take a look right here. So for number 5, in this case, what we would have to do, remember the formula, a sub n equals a1 r to the n minus 1. A1 is going to be 9. R is -4, n minus 1. And that's it. So that's how you're going to do 5, 6, 7, and 8. 1, 2, 3, and 4 are very similar to the ones in the notes, so take a look at the notes. Let's do number 10. I like number 10. We're going to find the first 5 terms here. So the first one would be if I put a 1 there. So 4 times -3 to the first, that's going to be -12. And now I'm going to square that. Remember, -3 squared, -3 times -3 is a +9. So +9 times 4 is going to get me 36. Okay, now we've got the cubed. -3 cubed, -3. Notice I'm doing the exponent first. That's because of PEMDAS. I'm doing the exponent before I do the multiplication there. So first we deal with the exponent thing. So -3 cubed. So -3 times -3 is 9, +9. And then +9 times -3 is going to be -27. -27 times 4 is -108. Okay. Notice, we could just be plugging this into your calculator. So in your calculator, you could be writing in 4 parentheses, -3, and then use the caret button to get all the way up to the exponent. And when you type that in, you should get 324. And then our last one, the 5th term, is when n is 5. Plug in 5, and we should get -972. Notice it's flipping between positive and negative. That's what happens with these exponents. So that's how we do the first 5 terms. As I say, best to use your calculator. Just plug it in. And then sometimes it's asking for a very specific term. So in this case, it's asking for 10. You would have to put 10 up here. And you plug that right into your calculator. So the parentheses buttons are on the left, down almost at the bottom, but not in the letters yet. And then the 1/2 is control divide. And then remember to use that caret, the little arrow, that'll get you up to the exponent. And if you did that to this one, you should get 9/64. 4. Check it. Make sure you get that. And that's how you do 14, 15, and 16. Your mission is to do all of the problems, and we'll talk a little bit more about this. I'm going to give you a nice little video before the quiz tomorrow so that you can check your answers to this homework and so that we can talk about what's going to be on the quiz. Thank you very much, and have a wonderful day.